Hello, my name is Bakr Dasuki. I'm a physics teacher in Cambridge International School, Kurdistan. Today our video is going to be for IGC SE2 for the grade 10 and 11. So today we'll start with Unit 8 about electricity. You can see it in page 171. Okay? So from 171 until 177. We'll start today about the electric charge. So sometimes when we are in the winter working on the carpet or wake up from the sleep, we touch the car door, we have electrical shock. Car door or anything metal in the kitchen, we have like small electric shock. So where do you think that comes from? First of all, the physics, we understand it or we study it for understand this kind of things, for understand everything around us. It's not just a subject that we study and pass it in this term or whatever, but we need to focus to understand everything is happening. Okay? That's why I need you to open your mind and always ask as much as you can to understand everything. So, where this electrical shock come from? When we have something called electric charge, this is called static electricity, this charge. So, when it's two charges, positive and negative, are in touch, if there's like more amount of positive or negative charges and touch the other, it's like negative, if a lot is positive and the few is negative. When they touch, they have this electrical shock. It's called static electricity. I mean, for example, when you wear a jacket from wool, okay, and you are full of charge because your movement or because touching the carpet or because whatever. So you will be full of charges, even negative or positive. For example, you will be full of positive charges, okay? Then you will touch something metal. For example, car door. Okay? Then when you come closer to your hand to touch and you find this electric shock, and you're like, why that came from? This is called static electricity because your body is charged by the positive charges and touch the metals are negative charges. So what's happening is the charges are jumping from your hand to the car door, okay? And now we'll talk how that will happen in the next point. So we say it's negative and positive charges, but why these positive charges jump to these negative ones? For example, let me explain about the perspex if it's charged with positive points. So if it's charged with positive and have two parts, if both of them are charged with positive after we rubbing them in wool or something, so we find them they are repelled for each other, so that means they're moving away from each other. Why? Because they are the same charge. Go to polythene, we also bring two bars are rubbed by wool or something and they are full of negative charges. So what's happening is also they moving away from each other. Why is the reason that? Because every two similar charges are going away from each other. But the thing is, if we bring one of perspex are charged, one perspex bar are charged of positive charges and one polythene bar that are charged with negative charges, we find they are coming closer to each other. The reason is because every two different types of charges are connecting to each other or coming closer to each other, and every two are the same. They're going far from each other, or moving away, sorry, from each other. So, but there's very important question we should ask ourselves. It's like, where the charges come from? Okay, there's positive, negative, blah blah blah. So where these charges come from? Thing is, everything in our life, it's made from very tiny particles, and these particles have many atoms. Okay, for example, as you can see in this figure, this atom, the atom have electrons, and you have nucleus, and the nucleus have proton and neutron. Usually the electron is negative or negative charge. The proton is positive charge, and the neutron, it have no charge. So usually the atom have the amount of proton and electron are the same. So the atom is stable, okay? But what's happening is, when some other charge, like for example this or that we see coming, they're giving more electrons, but these electrons will go away. If they're free electrons, will come away. That's what it give us, for example, the electric shock. Okay, so the power is not like the power. The definition of the power, it's not made up from nothing. It didn't come from nothing. Always the power is a figure transfer from thing to else. Okay, again, the power is a figure that already exists, but it just transfer from one figure to another one. For example, in this, so the power, it's already there, but just the electrons of these atoms have been separated and moved. That's what gives the power. Okay, now for example, how we gonna understand that? We bring a bar of polythene that charged as negative by a wall, and the wall will be more positive and the polythene will be more negative, and the compression here is rubbing the wall in the bar. The same as the perspex. So if it's full of positive charges and we rub it with the wall, so the wall will have more negative than usual, and the perspex will have more positive than usual. Okay, also the electrons will move there, and here the electrons will go there, or the charges, the positive one, will go there. So the electrons, when they are moved, they're like, here is focused, the negative ones, electrons, and here in polythene are focused also. So how we know how the current will pass? Thing is, we have two types, is conductors and insulators. So the conductors, they are, for example, they are metal. They can freely pass these free electrons. Okay, they can freely pass these electrons. So the electrons are not so tied to the nucleus. They are not so tight, so they can easily pushed away. So as a good types for conductors, metals are silver, copper, gold, aluminium, etc. And also, of course, for sure, as you know, the temperature or the metal things are good thermal conductor. Like if you put the spoon on the fire, after a couple of seconds and you find from the way you hold it, you'll find it will be warm or even hot. So watch it, don't burn your head. Then it's the insulators. The insulators, the electrons will be tightly to the atom, be tightly hold on it. So what's happening is they cannot easily pushed away from the nucleus. So as insulators examples, we have plastic, rubber, glass, air, PVC, etc. So this cannot give us electricity, or it's a bad conductor. The last part is semiconductors. The semiconductors they are very interesting because when they are cold, they are very bad conductor, but when they are warm, they are a good conductors. So semiconductor, let's say, is half by half. When they are cold, they will give you bad conductor, more to the insulators. But when they are warm, they give you good conductors, like a good one. As the two types, the most known two types from semiconductors is silicon and germanium. As at the end we see, here is normal cable, and this are two copper wires, as you can see in the figure in page 173. So this is normal cable, have two copper small bars or wires. So these are made of copper, for example. So they are covered by PVC, and this also. Why? We have to insulate them from the electricity that is here, because if it haven't touched here, it will be like a very big problem, because there will be contact between the neutron and the phase. Okay, and the end, this is for like the end of our video. I want you to focus that the things that happened today, and I want you to experiment this. Of course, I'm sure you remember that what's happened, but this static electricity and the thing we take, how the current is going by these things. This is our video for today. Thank you for watching. Keep safe, keep yourself safe, and wear your mask.